So what's on the agenda for today? So we're going to talk mostly about our experience on this particular project that we were on. So we're going to set some context, talk about what is blockchain so that we're all on the same page when we talk about it. And then what we're trying to do for this session today is sort of take you guys through the journey we've been through. And it's mostly just asking a lot of questions internally and then what are some of the answers we came up with.
So yeah, why context? So as consultants, a lot of our answers are it depends. So we wanted to make sure we sort of give you all the context because a lot of our answers were around this context. So basically, we were working for a startup that was backed by an energy and finance consortia. So these were big companies, Fortune 20 companies. And so we were in startup mode, but we were building for enterprises, and that's in possibly a lethal mix because you want to be agile and nimble in startup mode, but your customers are big, slow-moving enterprises, so it's hard. We were building for post-trade confirmations. So these are OTC trades, OTCs over the counter. We are also building some trade finance integration. So in commodities trading, there are lots of credit lines where money is blocked and there's a lot of potential for disruption. And cargo operations for a waterborne market. So that's once a commodity has been traded, how does it get delivered? And we were focusing on a waterborne market. So there's a ship on the right-hand side of the picture. And this startup wanted to operationalize in 3 additional markets. They wanted to go live in 6 months for their investor customers, or a subset of their investor customers, about 6 of them. And we had to ramp up to about 70 people for this delivery. And for those of you who know, the storming, norming, forming, performing theories, ramping up to 70 people is a big Herculean task to get everybody on the same page about context and what we're doing, etc., etc. And the last bit, which we're going to talk about mostly, blockchain. So the choice of blockchain was already made for us when we came in. That was Quorum, and it had little or no production history when we started. So, and we were in touch with the Quorum folks. And there was, we didn't have a live application for reference. And so that turned out to be one of the places where we had to invest the most. So yeah, that's the context. And then what is blockchain? Like, how many of you here familiar, worked with blockchain or played with blockchain? Okay, so very few. That was my position when I started as well. And I've gone through like different models of thinking about blockchain. Sometimes I think it's just a database that makes some specific trade-offs, and sometimes it's a mind melt to me on how it does these decentralized things. So I've been shifting through it, but because I was in this blockchain project, a lot of people asked me what's blockchain. I would explain it to them, and I found it much easier to remove it from technology and like take the example of a non-technology problem area. So that's what we're going to try here. So the left-hand picture is our attempt to show a soccer game that's going on. And as you know, in a soccer game, there's a scorecard and there's a referee that helps referee what's going on. In a blockchain world, so if this were a blockchain-based game, there would be no scorecard. So, sorry, I'll rephrase that. There would be no one scorecard. Yeah. Everybody would have their own scorecard. There would be no referee. So there's no one person who has the authority to say, yes, that's a foul, or no, that's a foul. So if there's a foul, all members of the playing teams need to agree that it was a foul. If there's a score, everybody needs to agree, yes, it was a score by this player. So you can imagine how chaotic this situation would be if everybody has to agree on it, and they have different incentives, right? Team A wants to win, so why would they agree with Team B that somebody had a goal? Luckily, blockchain is not built for humans. It's for computers, so things are much more saner, but that's how things go. This is a sort of more formal buzzwords that you hear about blockchain. Blockchain is all about shared, I say shared / distributed. Basically, all data on typical blockchains is available to everybody. It's decentralized, so there's no central authority controlling it. It's permanent and tamper-resistant. Now, there's an argument of whether it's tamper-proof or tamper-resistant. I'm not going through in it, but basically modifications are extremely hard. Even if you can modify it, it's very apparent that there's been a modification. They're programmable, so you can push executable logic in it. That programmable nature is generally referred to as smart contracts. And data integrity is very high. So any change on the blockchain is cryptographically verifiable. So you can go back in time and say, oh, who made this change? and prove to me that this change was made by this particular account or this particular person, etc. So those were the top, these are the typical words used for blockchains, public blockchains specifically. There's a new variety of blockchains that had come up at some point called enterprise blockchains, or which support some different trade-offs. So they support the notion of permissioned. So in public blockchains, anybody can join the blockchain, but in enterprise blockchains, there's a permission network. So that there's a point of permissioning a node to join the blockchain. And they also support the notion of private state. So again, in a public blockchain, any data you put on a blockchain is shared with everybody. In a private blockchain, you choose with which people you share your data. Now that's very contradictory, but it's some different trade-offs, and to gain something, you need to lose something. So that's the sort of deal. Enterprises love these bits because they're really spooky about their data being shared with everybody, as you can guess.
And our choice of Quorum was also because that was what Quorum offered. It was an enterprise blockchain.
Yes, yes, yeah. So Quorum's USP is those two sort of properties. Yeah, you're right.
So in the next section of our presentation, we try to model our thought process as a decision tree. So we kind of go through the sort of high-level decisions that we had to make along the journey.
Yeah.
So the first one was around what is the role that we want the blockchain to play in our application or in our system. So one is we could go with absolutely nothing. The second one is we could actually model this as a decentralized app, or dApp, that is very common in the blockchain world. Or we could go with something which you're a bit more familiar with, which is have a client server and maybe have client server on traditional dApp structure. What were the considerations when we had to do this? So one is blockchain dApp is all cutting edge technology, but we're building the solution and for an enterprise scale, for an enterprise solution and an enterprise client. And they are not really jumping at the idea of going with something that bleeding edge. They want something that they sure will work, something that they trust. And we know the client server model works. And there are a couple of other bigger trade-offs as well, which we'll cover as part of the rest of the presentation. But what does this look like when we talk about client server on the blockchain? So on the left-hand side, what you have are, we've represented circles as nodes, and the arrows that you see are basically the blockchain network that you have. So all communication happens only through the blockchain nodes or the Quorum nodes that we had on each of these circles. And if you blow up what's in this circle, if it was a traditional dApp, you would have your Quorum node and you would have just the front-end UI, which would be on React or something like that. And that would directly interface with the blockchain node. But what we did instead is we had a bit of client and server. So we had a Spring Boot application, which then interacted with our blockchain. And so that's how we ended up modeling our system. So what our choice was in the end was we went with a client server model on the blockchain. And then that brought us to the next question that we have, which is,
what is on blockchain? It just occurred to me that this sort of decision tree looks, well, at least to me, to my eyes right now, very neat. And oh yeah, we took this decision and then we made this choice, this choice. It was really chaotic and intense back then. So we're just trying to play it out as a journey right now. But yeah, so because of this sort of hybrid choice we'd made, that we'll be like a client server architecture on top of a decentralized network, we have to now figure out what actually goes on blockchain. And there are lots of technical reasons why everything shouldn't be on blockchain. One is storage profile. So blockchains, because they have this shared everything nature, their storage profile is very different to your traditional apps. So in traditional apps, your storage is proportional to what you're storing, and like, I don't know, maybe 1 to 100 times the number of consumers. But here it's proportional to the number of participants as well. So if you have more participants, all the data gets redundant, and then when the new person joins the network, they will download all of that data. So the storage profile is very different. Because of the need for everybody in the blockchain network to share that data and validate it, that means transaction times are slow. So when you're talking about near real-time applications, you can't really use the blockchain. So that's another technical reason for not putting anything on blockchain. And the third thing is, because things are permanent, it's next to impossible to implement forget-me type regulations. There are lots of things in the compliance and regulatory space which are at least in our knowledge today just not possible, because if you, let's say, put somebody's, browser history on a blockchain network, and then they say, well, according to European law, you should forget me. That won't be possible on a blockchain network because that data is shared across all the networks. There were lots of reasons why we couldn't put everything on the blockchain. So we were left with something. What something? And for that what something, I guess we thought that business collaboration was key, because apart from those technical reasons about what's not feasible, there's a cost value trade-off. So what we did is we had this sort of physical version of this on the wall in the office. We had these quadrants. So on the top left quadrant that says on ledger and decentralized was our quadrant for what's on the ledger. We had this off ledger decentralized quadrant, which is empty right now, but back then we thought we would find problem spaces or concepts that need to be off ledger but also need to be decentralized. When we did some more experimentation, we found out there is no real tool that can be both decentralized and not on the ledger, right? Like you end up building what is on the ledger. So actually then we deliberately moved things either on the left-hand side or down to the bottom. The bottom is centralized off ledger. So that's your typical like what's shared across the network. And we also had some local stuff. So it's not shared, it's for a blockchain node, but it's within that green circle that Lucy was talking about. And of course, like there's some examples in here. So on ledger, in our like soccer example, you would have a scorecard concept which is shared with everybody. Every team will probably have a defense strategy, and there's a small green and red on it. We'll come back to that in later slides. It's about whether the contract is public, as in visible to everybody, or it's private to a specific set of members. I guess the emphasis on this is there is a significant amount of effort to push concepts onto your blockchain network, even if you just want to deal it as the source of truth, and you need to be very careful about what value you're getting about it. So we actually did a workshop with our business stakeholders, explained to them in like 2 to 4 hours what blockchain was, and then went through each one of the stickies we had in our real world example, like, hey, there's a trade. Should the trade be off ledger or should it be on ledger? And we would talk through why is it important for them for the trade to be, I don't know, irrefutable or commercially confidential, etc., etc. And then that's how we build this, and that's how we decided. And then this became a living document. Every time there was a new business requirement or a new business concept, we would go back to this, talk to the business, understand what they're saying, and decide accordingly.
So we keep talking about something on the blockchain, doing the blockchain actually taking care of, you know, the interactions and all of that. So how exactly is this done? So we have this concept called smart contracts, which is how we interact with the blockchain and how we actually get action performed on the blockchain. So we have a sample here which we've put, like going back to our soccer analogy. So this is what a scorecard contract might look like, and this is in a language called Solidity, which is what Quorum lets you write your contracts in. And what we have here is we have like an event which basically you can define saying that a player has scored, and you have the logic that you want to implement when a score is incremented. If there are rules around which you want to do some validations and say, okay, is this a valid goal or things like that, that's something that would go in there. So this is something that you would write as your contract. This is your programmable or executable piece that ships to everybody that's on the blockchain network. And what happens is every time your system is you actually go live, this particular contract is then converted to ABI, and then it's deployed to all of your nodes in the network. So it's permanent, it's there. If you want to change or if you want to deploy a new version of it, we'll get into that a little bit later on. So at the end of the day, when you look at it, it's basically code, which is nothing but code as data. It's shared across all the nodes in the network. It's immutable. It's once it's there, once it's deployed, it's there permanently. Okay. So that brought us to the next sort of question, and I think Shodhan covered this a little bit earlier on, which is, okay, we've got our contracts now. How do we want to deploy these contracts? Do we want them to be public or do we want them to be private? And if you think about the examples, if you take a trade, which is a bi-party operation, you don't want everybody that's in the network to know who you've traded with and what are the details of the trade. So you want to be able to have a private transaction between two parties on the network. And like everybody is going to know that an action happened or a transaction happened between A and B, but they will not have the permissions to see what the details of that transaction are. And again,
it's not only, so they'll never have the data. It's the
it's never on their node.
Yeah, it's like the NSA level of security. So it's never, they don't see the data even if it's encrypted. They never get it on their node.
Yeah. And if you think about what could be public, it's something like cargo operations, for instance, like in the context that we were in, like cargo was something that everybody on the network would be aware of because it's not as confidential and it's public knowledge. So that was something that could be shared and the details of which could be viewed by everybody. So that's an example of what a public contract would look like. And I think just tying it back to the soccer analogy, like a scorecard would be a public contract that you would have, and maybe like a game plan or a game strategy that you would want to just discuss with a few players on the team would be a private contract. So this is just a visual representation of what that looks like. So here you can see that there is a private contract between A and B, C and D, E, F and G. So those lines represent the private transactions, and you have this gray circle across all your nodes, which is how a public contract would look like.
And the lines represent what data is available on what node. So if for the red line, for example, is only between A and B, so anything shared via that contract is not available on the node. So if you physically go to C's blockchain node and try to open it up, and like, well, it's software, but yeah, if you try to open it up and see that piece of data that was transacted via the AB smart contract will not exist at all. That was one of the key things. So I think in the end, we only had one public smart contract. Like all our smart contracts were private because that is what was most useful. So yeah, what was the next thing was whether the contracts are static or dynamic. And I must confess, this is sort of invented terminology. I don't really know if this is the right terminology. But as Lucy talked about, a smart contract, let's say we use Solidity to write it. It's compiled into ABI and it's deployed into the EVM. And then you can sort of start using it. Let's say there's a smart contract in our soccer game for the attack strategy, right? So typically what you want to do is for that attack strategy, you want to share or use that smart contract for your playing members only of your team, not the other team, because you don't want the other team to know what your attacking strategy is. And you could use the static mechanism of it. So basically, when your network is being instantiated, you would deploy the contract and say, hey, this is only for this subset of players of team A. But what if, I don't know, a player switches clubs? So they were in team A, they went to team B. Because smart contracts are on blockchain, you can't change their membership. So they have access to that smart contract, and now if you make any changes to their attacking strategy, they'll always see that data. So we wanted to reduce that blast radius of effect of people changing teams in this example, and in the real example, trading legal entities, changing mergers and acquisitions, and different business entities having different trading partners. So we want to reduce that blast radius. What we ended up doing is we did a smart contract per business entity that we were going to use. So in our attack example, for every game, you would initialize a smart contract with the players playing that particular game, and it will be just for that. And the next game, you would do the other contract. So that'll be the example of dynamic contract. In static contract, you would have one static contract for your attacking strategy, and then the members of that contract can always see it. So that's why we had to move to dynamic contracts. They were much more complicated and we ran into lots of latency issues, but we had to do that. The other question we had to answer was how much business logic. So in any tech stack, I guess in your traditional tech stack, there's always this question of, well, is this business logic in your middle tier, or should it be in the UI layer, or should it be in your repository layer? Similarly, here we had to answer the question, well, should this validation go into your smart contracts, or should it be on your server side, or those were the main two questions. And we wanted to reduce the surface area of smart contracts as much as possible because we knew it was going to be difficult. So we decided to only do some of it. So once we did all of that, so we did private smart contracts, we were dynamically deploying them, and we had some business logic in it. The next obvious challenge was incremental delivery, right? Like we still want to do our business usual of incremental delivery. It's how do you achieve that in immutable permanent code is a big challenge, and also bug fixes, right? No matter how awesome our safety nets were, you can only guarantee there's going to be a bug. And you can't just fix a bug by changing code. In a traditional application, what you do is you change your code in your repository, push it, it gets built. maybe if it's a jar or something, you replace the old jar with the new jar. You can't do that anymore. That code is permanent on the blockchain. So we had to come up with like a way to get around this, because we still wanted to do incremental delivery and we needed some mechanism to deal with bug fixes. So what we did this linked list type model, and so this diagram tries to represent that. So here we're showing 3 contracts, which are the 3 boxes on the right hand side, and a registry, and all of those contracts are, let's say, in that first Genesis version, V0. And to actually, when we wanted to do incremental delivery, so maybe there's a change in the scorecard contract, we had to write a wrapper around the old contract. So that's a V1 wrapper on the right hand side that points to the old V0 smart card contract, and that's how the layers would work. So it formed this linked list level style. Also, if there's a new team or a new game that's being played, then that's a different version of a smart code contract, because we had these dynamic contracts. It's a whole new version of smart code contract which doesn't have a link to V0, because V0 didn't exist when we had deployed that. So it turned out to be a pretty complicated setup, and but that's what we tried back then.
Yeah, and I think going into it, like we knew as we were rolling out the first version and then the second version that this was not going to be a sustainable mechanism for us to go forward. Testing became really expensive. Writing code in itself was really expensive, because you always needed to keep in mind what was already on the blockchain, what version was on the blockchain, and how that was going to be compatible with what's coming next. And at one point when we had to test it out before going live, we had to actually have 2 networks, blockchain networks, one to test the old one, and then the other one to test how that upgrade would work, which added a lot more complexity to our testing process. And there was also like the whole mechanism of retracing and going back and creating that linked list. So every time you deploy a new version, you have to iterate over all of your existing contracts and then link them back up to actually form that chain, which added like I think easily 90 minutes to our deployment cycle, which was crazy. And every time, if you go live and you know there is for some reason you have to roll back, that's again another 90 minutes. So it just made everything more tedious. So we knew that, okay, we need to choose an alternate way to move forward. So that brought us to, it actually took us a step back really, because we went back and asked the question, which was how much business logic do we really need on the blockchain? And we did go with some business logic in the beginning, but that's what got us into the whole linked list and the versioning issues that we had. We then went back to, okay, what if we don't have any business logic on our blockchain? What if we move that to the server? How can we still achieve, you know, the shared, decentralized, permanent, tamper-resistant promises that the blockchain have without actually having any business logic? And what we ended up, or what we're trying out now, is using the blockchain as an event bus. So it basically just it stores and stores and emits events, and basically that is shared. So we feel like we've achieved or we are achieving what the blockchain promises, without actually the cons of the managing the version upgrades and things like that.
So yeah, in summary, business collaboration is key. Blockchain is often seen as a technology solution, but it's actually what business value does it give you. We found that as one of the main useful exercises. In the Kurian space, smart contracts don't support things like upgradability. So we are, so as Lucy talked about, we have now have a version where a lot of it has been pulled out of smart contracts. So we would advise very considerate usage of smart contracts. There are other blockchain implementations, well, if they're blockchain, like Coda, where upgradability is a first-class citizen, so there could be different options there. And be ready for multiple pivots. Like, we've not yet gone through the full list of things we went through. We probably went through a dozen iterations in this 6-month process. Testing and learning is key when dealing with novel technologies. Yeah, that's all.
That's about it.
Thank you.
Yeah.